I came in front of you to give the clarity on light vehicles. I see many students, they face problems in science, especially in physics. So here today we'll discuss what different type of problems we have in light, mirror related, lens related, the reflection related, diffraction related, both. We will discuss what we have to focus more. So here we should have idea about what are different formulas we have related to the concepts. Especially first let us know about the reflection and then we will discuss about the refraction also. First, reflection related what important formulas we have. That is mirror related what important formulas we have and how to take the sign convention, which should be taken positive, which should be taken negative. Okay, now let us see here. First mirror formula we have. This we have to remember important first one. What is mirror formula? 1 by V plus 1 by U is equal to 1 by 1 by V plus 1 by U is equal to 1 by F. So here we have to know what are these terms also. Here we know what is V. V indicates image distance. V is image distance and then U is what? Object distance. Object distance. U is object distance and F is focal length of the mirror. Focal length of the mirror. So here 1 by V plus 1 by U is equal to 1 by F is mirror formula. In that V means image distance, U is object distance, and F is focal length of the mirror. Now, after this, we have another formula magnification. We have magnification two formulas. This is about mirrors. Magnification, we can find out magnification is equal to in one way HI by HO. What is HI here? HI is height of the image. HI means height of the image and HO is height of the object. Height of the image by height of the object will give you magnification of the image. That means what? Whether image is increased, whether size is enlarged or reduced, magnified or diminished. We can find out by using this magnification formula HI by HO. And one more formula also we have, V is equal to minus V by U. Already I told you what is V, what is U. V is image distance, object distance. U is object distance. So in two cases, two ways we can find either by doing HI by HO or minus V by U. In any one of these two, you know, we can find out the magnification. That is whether image is size increased or decreased. And by these two, we can derive one more relationship between height of the object, height of the image, and image distance and object distance. From these two, we can also write HI by HO is equal to minus V by U. So these are the important formulas that you need to remember related to mirrors, that is reflection. And once you know the formulas, we should also know sign convention. What should be taken positive, what should be taken negative. Here already in mathematics we have coordinate geometry, the x-axis, y-axis. If you remember that, based on that, this also we can remember easily. So let us see. We know this is x-axis, this is y-axis. This is important because most of the students they confuse in taking sign, positive or negative. So let us know this how to take. What all distances you are having towards right side, you have to take it as positive because we all know this is what positive x-axis. This is positive. So like that you remember all the distances towards right side we take positive and all the distances towards negative whatever you have you will take them negative. So similarly above the x-axis above the x-axis we take all values positive and below the x-axis whatever you have we will take them negative. Now, in which case, what we will take positive, what we will take negative. To know this, you should also have an idea about the ray diagrams, image formation, image formation, ray diagrams. Also, you have to know where in which point we are keeping object and at what point we are getting image. Based on that only, either you are getting image right side or left side, you will know, and based on that only, you can know whether the should be taken positive or negative. But some values fixed value. They are not depends on their positions. They are always positive, always negative. Let us see what are fixed sign they have. So for example, focal length is a fixed value. It will not change according to the object position or image position. Focal length of concave mirror. Suppose if it is a concave mirror, focal length should be taken. Focal length should be taken negative. If it is concave mirror, focal length should be taken negative. If it is convex mirror, focal length of convex mirror should be taken positive. We have to remember this. In question, if it is given, it is concave mirror. You have to take its focal length negative. They do not mention in the question. Where they mention only concave mirror. So whenever you see that word concave mirror, you have to understand it is negative. Similarly, if they mention in the question convex mirror, focal length, you have to take it as positive. This is one very important point you have to remember. Next, object distance. You remember, see here, like this, we will be having concave mirror. This is what pole, here focus, here center of curvature, like this will be there. So focal length, because it is towards negative, we will take focal length negative. And object we always keep in front of the mirror because always we keep object we keep always in front of the mirror. It is left side of the mirror. Since it is left side of the mirror, object distance is always negative. In every case, object distance, irrespective of what kind of mirror you are taking or lens you are taking, even lens also or mirror also, it should be taken always negative because we will keep this towards the left side or in front of it. Object distance is always negative. You should take it as object distance, you have to take it as negative. So you have to remember focal length of concave mirror negative, focal length of convex mirror positive. Object distance always, in any case, it is negative. Now coming to image distance. Image distance depends on position of the image where it is coming. In concave mirror, if you see in concave mirror, if you remember the table, object position and image position, in all the cases when you keep object at infinity or beyond C or at C, between C and F or at F, between F and P, this is different case, but in all these cases, at infinity or beyond C, at C, between C and F or at F, in all these cases, what happens? In all these cases, image forms same side of the object. That is left side only. And real and inverted. It is a real and inverted image forms and it forms left side. So in all these cases, in concave mirror, it is negative. It is negative in five cases. It is negative in five cases, but only in one case. An object is kept between focus and pole. When object is kept between focus and pole, image forms behind the mirror, right side of this, right side of the mirror, behind the mirror. So in this case, it is positive. Virtual and direct image will be formed. So that's why it is what? Positive. In one case, only in one case, it is positive. This is in case of concave mirror. Concave mirror. So you have to remember if object distance is given more than the focal length. If object distance is given more than the focal length, see between if object distance less than the focal length, what does it mean? It is between f and p. If it is between f and p, your image will form vaccine, your image distance should be positive. If object distance is more than this, more than focal length, that means you are keeping object in any one of these five cases, then your image forms same side of the mirror, that is left side of the mirror, you get negative and real and inverted image. So hope you understood this. In convex, in case of convex, hope you remember this figure also. In case of convex, only there are two cases. One is that when object is at infinity and another is between anywhere, infinity and pole. In both the cases, it forms right side only. Virtual and direct image it will form and diffuse image it will form. So what if it is convex mirror? Image distance will be positive and height of the image also positive because it forms right side of the mirror and it is erected image, virtual and direct image. So you will be having V. This is in case of concave mirror. This is in case of convex mirror. In convex mirror, you will be having only positive distance, that is positive image distance. And height of the image also positive because it is erected image. So let us discuss about height of the image only. Height of the image also same like before. In five cases it is negative, in one case it is positive in concave mirror because whenever image is real and inverted, its height of the image is negative. Whenever image is virtual and direct, height of the image is positive. If it is erected image, you should take height of the image positive. If the height of the image is positive, you should decide it is erected image. If height of the image you are getting negative, you should decide it is inverted image. Inverted image. So in convex mirror, you get only erected image and diminished image. So what you will get only positive height of the image, you will get only positive in case of convex mirror. But in case of concave mirror, in all the five cases, you will be having inverted image. Height of the image will be negative. So that is okay. Height of the object is always positive because object will keep always above the principal axis. So when it is above the principal axis, whatever distance above the principal axis, it is positive. Hope you got some idea about what are the important formulas related to reflection and how to take the set dimension. So let us see, let us apply some, let us do some problems to understand it better. Happy Independence Day, only few people have joined, okay, no problem. Hope this will give you full clarity about light. Right, now let us see some problems related to mirror. Video, audio clear to you? You are understanding everything? It's everything clear? Can you see the font what I am writing on the board? Sir, say, sir, where will be the focus behind the image or front of object? Okay, we will discuss on this. So let's see this problem. In this problem, what it is given? An object is placed at a distance of 10 centimeters from a concave mirror of focal length 20 centimeters. So what is given here? Object distance is given, object distance is given, and focal length is given. An object is placed at a distance of 10 centimeters from a concave mirror. This is important. We have to underline this. So what concave mirror it is? When it is concave, we should have idea about sign convention, and what is given? Object distance is given. It is object distance. So let us note the values what we have. Solution. What it is given here? Object distance is given. Object distance. Object distance, how we denote? Object distance is denoted by u, and it is given 10 centimeters, and I told you object distance should be taken always positive. So you should be taken all the object distance should be taken always negative. So you should be taken negative minus 10 centimeters. Object distance is minus 10 centimeters. And focal length of concave mirror is given because it is concave mirror. I said take focal length negative. So we should write focal length of concave mirror. F is given minus 20 because it is concave minus 20 centimeters. So these two, this information is given, and they are asking first to draw the ray diagram for the formation of image. We should also calculate the image distance. You have to find image distance. So if you observe how to draw the ray diagram by seeing these two, you should understand what you should understand. It is a concave mirror and object distance is 10, focal length is 20. So if you draw the ray diagram, how it will be here and one. This is concave mirror. Let's take this is principal axis. Now this is B, this is F, this is C. Now if you observe focal length is 20, focal length is 20 centimeters, focal length is 20 centimeters, but object is kept at 10 centimeters only. Means what? Less than focal length. I told you just now, if object distance is less than focal length, it is between F and P. So where it is now? Between F and P. Here, object is here. Object is kept between F and P. So this distance is 10 centimeters. You should have idea when object is kept between focus and pole, our image forms behind the mirror because it is concave mirror. An object kept between focus and pole, image forms behind the mirror and is a virtual and direct. So how image will form now? We draw one ray parallel to principal axis like this, and another ray falling at pole. And by using rules of array diagrams, what we do whenever a ray is parallel to principal axis, after reflection it passes through focus like this, and the ray which is falling at pole makes same angle. Angle of incidence is equal to angle of reflection, like that it reflects back. So now we have to extend these two to get the image. We have to extend other side to know where they are exactly meeting. So now let us see. If you extend these like this, they will come. They will be meeting at one point here. Now this will come. So here, if you observe, they both are meeting at one point. behind the mirror. So at that point, image will form. So this is what formation of image behind the mirror. So in this way, we can find out ray diagram. This is what ray diagram. First question answer. And the second question answer, ray diagram is over. Now they are asking to find image distance. This is the. Now they are asking to find image distance. To find out image distance, we have to use mirror formula. What is mirror formula? 1 by V plus 1 by U is equal to 1 by F. In this, we already know U minus 10 and F minus 20. So 1 by V plus of 1 by minus 10. We should be very careful about the sign here. 1 by V plus 1 by minus 10 is equal to 1 by minus 20. So transpose this that side. 1 by minus 10 you have to transpose that side. Then 1 by V is equal to 1 by minus 20. This 1 by minus 10 will become 1 by 10. That's 1 by 10. Because it is minus after we are saying that's to become plus. Now we should take the LCM of these two. We can take LCM of these two as 20 because 20 and 10 we have. Since we have minus 20 here, we should multiply minus 1 to get minus 20. Okay, because we have taken here LCM 20 plus 20. So to get plus 20, we should multiply minus 1. So it's minus 2. And here it is 10. To get plus 20, what should be multiplied? 2 should be multiplied. So we get 2 here. So we get 1 by V is equal to minus 1 plus 2 by 20. That is 1 by V is equal to minus 1 plus 2 is 1. 1 by 20. So therefore, image by this we understand it is forming behind the mirror. So whenever it is forming behind the mirror, it is virtual and direct. So next one, what in question you will see what they are asking to write. Write two characteristics of the image form. So what are the two characteristics? Like we can write image is virtual and direct one. And because it is that side, one point, and one more point we can say it is magnified image. We know whenever it is forming behind the mirror, that is magnified image. So magnified image is magnified. So so these are the characters like this. Long answer type or 3 marks questions will be given like this. You should analyze the question completely and then try to give the answer. You'll get full marks. Hope you understood this. Now let's see next question. Another question. In this question, what it is given? An object of 10 centimeters height is placed at a distance of 36 centimeters. Your figure they are not asking, but it is completely numerical. So here what information is given, first let us write. An object of 10 centimeters height is placed. So height of the object is given at a distance of 36 centimeters from a concave mirror. So height of the object is given. I told height of the object should be taken always positive. So it is HO is equal to plus 10 centimeters. First point we know. And the second point height of the object is 10 centimeters and one more object distance is given. U should be taken always negative I said. So U should be taken minus 36 centimeters. And one more what focal length also given. So focal length f should be taken because it is concave. I told you again, it is very important what kind of mirror it is, concave mirror. So focal length should be taken negative. So it is minus 12 centimeters. So you can analyze here also because it is concave mirror. You get full idea, better roughly draw like this so that you will have better idea what image distance you have to get. So this is pole, this is focus, this is center of curvature. Roughly if you draw, then what is focal length? It is 12 centimeters. This is focal length. But what is object distance? Object distance is 36 centimeters. Means how many times more than focal length? Three times more than focal length. Two times if it is exact, you get center of curvature. Now three times means here, object is here. Here means what? Object is beyond C. By this, you should understand an object is beyond C. Your image should form between C and F and is real and inverted. Diminished. Diminished real and inverted. Like this you have to get. So it should be more than F, less than R, capital R. So let us see how to find out it. Now our formula is what? What is our formula? 1 by V plus 1 by U is equal to 1 by F. So 1 by V plus 1 by minus 36 is equal to 1 by minus 2. If you transpose 1 by minus 36 that side, 1 by V is equal to 1 by minus 12 minus if you go that side, it comes plus 1 by 36. Again we take LCM, LCM is 12 and 36, LCM is 36 only. But here minus 12 we have, to get plus 36 what we have to do? Minus 3 we have to multiply. Okay, so if you multiply minus 3, we get plus 36. So it is what? Minus 3 plus here 36 we have already. So it should be written 1 only because already you have 36, nothing to be multiplied. So 1 by v. So what is 1 by v now? Minus 3 plus 1 is minus 2 by 36. After cancellation, we get minus 1 by 18. So by this, we get v is equal to minus 18 centimeters. Oh, you understood how to do? See, it is matching our analyzation. See, 12 centimeters, it is 24 centimeters. Up to here, 24 centimeters. This is 12 centimeters. We got 18 centimeters. Means what? Exactly between C and F. And you got negative. That means what? You got a real and inverted image. So according to our diagram, play diagram format only, you got result also. Your answer is correct. You can verify like that also your answer correct or not. So here, first one we got image distance minus 18 centimeters, minus 18 centimeters. Now nature of the image. First one, image forms it. That is right. Image position. Image position is at 18 centimeters in front of mirror. We can write like this. First point. Second point, we have to decide what is the nature of the image because it is in front of the mirror and negatively what image is real and inverted. Image is real and inverted. And next point, we have to find height of the object. So height of the object, to find out height of the object, what is the formula? I told you one formula, HO, HI by HO. HI by HO is equal to minus V by U. So in this HI we do not know, HI we have to find. HO is given 10 centimeters. So HI by 10 is equal to minus V. V, how much we got? Minus 18. So minus 18 by U is what? U is minus 36. Minus 36. So it is minus V, no? So minus of minus we have to do because we got V minus, but we have here minus V. So what? Minus of minus 18 we have to do. So by this what we get? Hi by 10 is equal to 18 by minus 36. So after cancellation it is equal to 1 by minus 2. So if you do cross multiplication, minus 2 hi is equal to 10. Hi is equal to 10 by minus 2 So HI is equal to minus 5 centimeters. Minus 5 centimeters. Why we got minus? Because it is inverted. When it is inverted image, height of the image will be negative. Negative affected. So you should be very careful about this minus plus. Somewhere if you write small mistake, your answer will go wrong. So it is inverted means that's why you have to get out of the image negative. And it is diminished. You can observe here height of the object is 10 centimeters bigger, and height of the image is 5 centimeters. Means what? It is diminished. You have to get a diminished image. Real and inverted and diminished image of this. So according to our concept only we got it, so it is correct. So this is okay. This is one more problem we have seen. So hope you got idea about how to do problems related to concave mirrors. Now let us see one two problems related to convex mirrors. Convex mirrors. There is so many problems we have. How much more you practice, that much you will be perfect. I can tell you that what final exam compulsory you get one problem from light top. So it is better to be perfect in numericals of light and electricity. Electricity and light, numericals will be there and there will be compulsory question in the final exam. Try to be perfect in using topics. So, once. This is convex mirror related problem. So here also what information we given, let us see first. In this problem, again object is kept at a distance of 5 centimeters. Object distance is given 5 centimeters. Student of a convex mirror of focal length 10 centimeters. Focal length is given. So it is important what kind of mirror it is. Convex. So focal length should be taken positive. We know object distance always we take negative. So let us write the given information first. Solution. Object distance is given. Object distance. How do we denote u? U is equal to how much it is given? 5 centimeters, but we will take minus 5 centimeters. And one more focal length. Focal length, but it is what kind of mirror? Convex mirror. Focal length of convex mirror. Convex mirror, because it is convex mirror, focal length should be taken positive. F is equal to plus 10 centimeters. 10 centimeters. Here we should be careful. Now we have to find position, magnification, uh, and nature of the image, all the three. So we will write formula 1 by V plus 1 by U is equal to 1 by F. Now let us substitute in this. Then 1 by V plus U is how much? 1 by minus 5 is equal to 1 by F, 1 by 10. So transpose this that side, 1 by minus 5. Then we get 1 by V is equal to 1 by 10. This is minus, no, after sending that side it will become plus 1 by 5. 1 by 10 plus 1 by 5. Now we will take LCM here. LCM of 5 and 10 is 10. So 10 is there. Then here already 10 is there, nothing to be multiplied, so it is 1. But here only 5 is there. So we should multiply 2 to get 10. So we multiply 2 to the 1. So we get here 2. So what it is 1 by V is equal to 3 by 10. 1 by V is equal to 3 by 10. Then V is equal to 10 by 3. V is equal to 10 by 3. You can keep like this, or if you want in decimal form, you can cancel it. We get 3.33 or 3.3. So we got here positive. Why we got positive? Because in convex mirror we get always a virtual and direct image. Our image forms always behind the mirror, virtual and direct image, and image distance is always positive. Even image height also positive. Magnification also positive in convex mirror. Whenever image is real and inverted, magnification will be negative. If image is real and virtual and direct, magnification is positive. So now let us see how to find out magnification. They are asking to find out magnification also. So magnification formula one is hi by ho, but here hi we do not know, ho also we do not know, so we cannot find out. We can find out by using minus v by u. Minus v by u. By using this formula we can find out because we know v and u. So now m is equal to, let us substitute this value. V is equal to 10 by 3. V is equal to 10 by 3 only we will substitute. So what? V is equal to minus 10 by 3. Why it is positive, but answer formula is negative. So minus 10 by 3. This is V value. By U value is what? U value, U is equal to minus 5. U is equal to minus. This is the minus 5 means minus 5 by 1. Now we'll take its reciprocal. M is equal to minus 10 by 3 into 1 by minus 5. We will take it reciprocal. So 1 by minus 5. Then minus minus cancel. 5 1s are 5 2s are. So mu is equal to 2 by 3. So magnification is 2 by 3 means it is less than 1. You know what it is? If you change this in decimal form, it is 0.66. Less than 1. Less than 1 means what? It is diminished. Magnification is positive, whatsoever, but is diminished image. M is equal to 0.66. Maybe low image. So this is what magnification. And what kind of image it is? Image is virtual and direct. Because they are asking nature also. Virtual and direct. Virtual and direct image, diminished image. So like this, we can use convex mirror related problems. Convex mirror related problems also we can do in this way. Now let's try one more convex related to get more idea. Question number 22. Another problem. See here what it is given. An object is placed at a distance of 10 centimeters. So again, what it is given, object distance is given. Given object distance. U is equal. Object distance should be taken always negative, minus 10 centimeters. And focal length is given, convex length. Convex because it is convex. Focal length of convex. Convex mirror. F is equal to 5 centimeters. Because it is convex, you have to take positive only 5 centimeters. This is very important. I see most of the students they do problem correct. Only because they do not read question properly, convex or concave, they take that symbol wrong. If you take that minus plus wrong, your entire solution will be wrong. So you be careful while you are taking the values, which is positive, which is negative. Now, they are asking to draw the ray diagram also. Now it is a convex mirror. Convex mirror we will take like this. This side we will be having focus and center of curvature, and this is what pole. Like this we will be having now where object will be kept in front of the mirror. So like this we have it like this we will keep object will be kept this side. Let us take this here it is the object. Now focal length is what? Focal length is 5 centimeters. Okay, but now one ray we will take parallel to the principal axis. One ray we will take parallel to the principal axis, and other ray you can take through focus. So till here, after that they reflect back. So rays will be reflecting back. If you extend other side, how will it be like this? So because it is passing, it is parallel to principal axis. One of the ray parallel to principal axis, it passes through focus like this. It appears like coming out of the focus. Like that it will be there. And one more, because we take it passing through focus, we can take this as passing through center of curvature instead of focus. So we can take like this, passing through center of curvature, then it extends like this. So the ray which is passing through center of curvature, there will be no deviation if it goes the same way. So what? There will be no change in the path. Now where these two rays are meeting, these two rays are meeting at this point. So this is what virtual and direct and diminished image and image forms between 4 and 2. It's like that ray diagram will be there. This is what ray diagram. Now arrow marks you have to keep. So like this it will be there. Now let us see the next problem what it is. B. State two characteristics of the image form. This is A now. What are the characteristics of the image? Because it is forming right side it is virtual and direct. Virtual and direct image. And one more what? It is diminished image. Whenever it is called as scalar, virtual and direct and diminished image. Only two. Diminished image. Now C. Now in C what you have to find? You have to calculate the distance of the image form. So here we use 1 by V plus 1 by U is equal to 1 by 1 by V plus what is object distance? Minus 10. So 1 by minus 10 is equal to 1 by F. F is 5, so 1 by 5. So here also we get same like before. 1 by V is equal to 1 by 5 plus 1 by 10. So again LCM is 10 only. We have 2 plus 1. So we get 1 by V is equal to 3 by 10. Same answer we got at before. That is what V is equal to 10 by 3. So V is equal to 3.33 centimeters. This is what the way how we find image distance. Numericals related to concave mirror, convex mirror, magnification, ray diagrams. Now let's see some problems related to refraction. This is about reflection, about refraction. So to know about refraction here again, what you have to know about lenses, you have to know. Before we are going to that, we have refractive index formula. What is refractive index formula? Absolute refractive index. Refractive index also we have some problems. Refractive index is nothing but it is one formula we have it is speed of light, speed of light in air or vacuum by speed of light in medium. Speed of light in given medium, whatever medium refractive index they are asking to find, that medium, what is the speed of the light in that medium you have to find. This is what absolute refractive index. Absolute refractive index whenever you want. Speed of light in air or vacuum, which is constant always, that is 3 into 10 to the power of 8 meters per second, it will be, that will be given fixed value. But speed of the light in medium will be changed according to the medium what you are taking. So based on these two, by calculating, by finding the ratio of these two, we can find out refractive index. This is one formula. And another formula we also have refractive index. We denote it with n. N is equal to sin I by sin r. What is I here? Angle of incidence. And what is R here? Angle of refraction. Sin I by sin r. This is another formula. We also call it as Snell's law. This is always constant ratio of sine of angle of incidence to sine of angle of refraction is always constant. That is refractive index. That is second law of refraction also. So this also one more important formula to remember related to refraction. So one is speed of light in air by speed of light in given medium. One more also we have, if it is not absolute refractive index, you want refractive index of one medium with respect to refractive index of another medium. Here also, instead of giving A, we will be having another medium, one more medium. So refractive index of speed of light in medium 1 by speed of light in medium 2. So you will understand by doing the problem. You will see some problems. You will understand better. And coming to another one, lens also we will discuss now only what are important formulas we have. Lens formula we have, like mirrors formula, we also have lens formula. Lens formula is what only one change, that is 1 by V minus 1 by U is equal to 1 by F. This is lens formula. And here also magnification, we have magnification is equal to 1 is HA by HO as it is. But another is magnification is equal to plus V by U. You should not confuse about this. There 1 by V plus 1 by U is equal to 1 by F in mirrors. But here 1 by V minus 1 by U is equal to 1 by F in lens. Here we will be having plus in mirrors, minus in lens. And here magnification also minus in mirrors, plus in lens. These two you have to know. And by using these two, we can write one more formula, HI by HO is equal to V by U. This is one more. Now, of this, coming to sign convention, same like before only. If it is concave lens, it should be taken negative. Focal length should be taken negative. And if it is convex lens, focal length should be taken positive. Similarly, object distance is always negative. Image distance again depends. If it comes left side of the lens, it is negative. If image is forming right side of the lens, it is positive. Object height is always positive. Image height depends. If it is real and inverted image, it will be negative. If it is virtual and direct image, it is positive. Now let us see some problems so that we will understand better. Now one problem we will do refractive index related. Refractive index related. So here it is given one problem. Here in this problem, What it is given a beam of light passes from air into a substance X. If the angle of incidence be 72 degrees and the angle of refraction be 40 degree, calculate the refractive index of the substance X. So here clearly it is given angle of incidence and angle of refraction. So we have to use the formula n is equal to sin I by sin R. So refractive index, what is the formula? N is equal to sin I by sin R. Here we know I is equal to 72 degrees is given, R is equal to 40 degree. We should substitute these in the formula. Then what n is equal to sin 72 degrees by sin 40 degrees. But what is the problem here? We do not know 72 degrees and 40 degrees. So sin 72 degrees and sin 40 degrees we do not know. But in question it will be given like this. So now what it is, n is equal to sin 72 degrees is 0.951 by 0.642 in question only to be mentioned, which is nothing but 951 by 642. We can leave like this or you can convert this into decimal format. So then we will get the refractive index. For example, if you convert this into decimal format, what we do? 951 we divide with 642. We take one time 642 and remainder here 11 minus 2 9, 4 minus 4 0. Okay, 9 minus 6 3 309. So point will take 0. So again, approximately 4 times we get. So approximately what it is? N is equal to 1.4 something we get. So this is what refractive index. The way how we find refractive index when angle of incidence and angle of refraction is given. Hope you understood this. Now let's see one more. Let us see this. Light enters from air into glass. Glass plate having refractive index 1.50. What is the speed of the light in the glass? If this type of question is given, how to do it? So here in this, really what is given? Refractive index of glass is given. Given refractive index of glass is equal to 1.50. Refractive index is given. And one more what is given? Speed of the 3 into 10 to the power of 8 meters per second is speed of the light in air or vacuum. Speed of light. You have to remember, even though it is not given, now on you have to remember it. Speed of light in vacuum or air will be equal to 3 into 10 to the power of 8 meters per second. Now we have to find speed of the light in glass. What is the formula? Refractive index will be equal to speed of light in air or vacuum by speed of light in glass. This is the formula. So n value is given 1.5, 1.50 is given 1.5 is equal to 3 into 10 to the power of 8 by meter per second by here speed of the light in glass we don't know. So let us write this as V. Now we transpose V here and 1.5 here. Then V is equal to 3 into 10 to the power of 8 by 1.5. Now this 1.5 and 3 we can cancel. 1.5 ones are 1.5 twos are exactly. So what is V now? 2 into 10 to the power of 8. 2 into 10 to the power of 8 meter per second. This is what speed of light in glass. Speed of light in glass. Hope you understood how to find speed of light in glass, like refractive index related problems, how they are going to be. So, like this only, sometimes both the speeds will be given, how to find out refractive index, or angle of incidence and angle of refraction will be given, how to find refractive index, or refractive index and speed will be given. You have to find speed of light in another medium. One medium it will be given, another medium you have to find. This is one way. Now let us see one or two problems in lens. Then we will conclude. If you have more doubts, one more session we will conduct. Now, two, three problems related to lens. Yes, here convex lens. First, we have problems related to convex lens. Here in this problem, it is lens related. So, first, what is given information, right? Given focal length of its convex lens. So, it is positive. Given focal length of convex lens is equal to 10 centimeters. So it should be taken positive because it is convex lens. Positive you have to take. Convex lens of focal length 10 centimeters is placed in a distance of 12 centimeters from the wall. So lens is kept at 12 centimeters from the wall. How far from the lens should an object be placed so as to form its real image on the wall? So what here focal length is given and see here like this. Wall where it is kept it is given and focal length of the wall is given. So what image distance is given? They are asking where object should be kept so that image forms on the wall. Means what? Because image is forming on the wall and wall where it is kept also it is given. So what image distance is given and focal length is given. You should read question carefully. Convex lens focal length 10 centimeters is placed at a distance of 12 centimeters from the wall. So lens is kept at 12 centimeters away from the wall. So what it is given here, the distance between wall and the lens is given. And where image is forming on the wall. So what it means, image distance is given. The distance between lens and the wall is nothing but the distance between lens and image. So image distance is given. And it is because it is forming on the wall and here very important which type of image it is, whether it is virtual image or inverted image, real image. If it is virtual image you have to take sign in a different way. If it is inverted image you have to take sign in a different way because it is a convex lens. In a convex lens we know all the images which form this side will be inverted, real and inverted. And all these real and inverted images can be obtained on the wall. Only real images can be captured on the wall or on the screen. So by this you should understand because image is forming on the wall, it is a real image. When it is a real image, it should be taken right side because it in lens real images forms right side. In mirror, real images forms left side. This is very important observation. In mirror, real images forms left side. In lens, real images forms right side. So, if it is real image in lens, you should take its sign positive. If it is real image in mirror, you should take its sign negative. There positive, here negative. Because now it is lens and it is real image. How do we decide it is real image? Because it is forming on the wall. Because it is forming on the wall, it is real image. Because it is real image and in lens, we should take image distance positive. So your image distance is given. Image distance V is given 12 centimeters and the 12 centimeters should be taken positive because it is real. Real image will form right side of the lens. So 12 cm plus 12 centimeters. Now we have to use lens formula 1 by v minus 1 by u is equal to 1 by f. So in this process, anywhere if you take one sign wrong, negative or positive, if you change it, your entire solution will be wrong. And formula also if you confuse, instead of mirror if you use lens or instead of lens if you use mirror, then also it will go wrong. So you must be very careful while doing these problems. You should have full clarity in which case how it should be taken. Now let us substitute here 1 by 12 minus 1 by u is equal to 1 by 10, 1 by 10. Now we transpose 12 that side, then minus 1 by u is equal to 1 by 10 minus 1 by 12. Now LCM of 10 and 12, how much it is? 60. We can take 60 as LCM. So how much we should multiply to get 60 here? 6 should be multiplied. So I am multiplying 6 here. That side how much I have to multiply? 12 I have. So 5 I should multiply. So minus 5. So what it is 6 minus 5 by 60 which is 1 by 60. So what is minus 1 by u is equal to 1 by 60. That means what minus u is equal to 60. Therefore u is equal to minus 60 centimeters. You have to get image object distance always negative. If you get object distance positive, your answer is wrong. So you have to go back again check it where you went wrong. So object distance should be negative. So we got object distance negative. Now where object should be kept to form image on the wall, object should be kept at minus 60 centimeters from the lens so that image forms on the wall. Clear image will be forming on the wall. Hope you understood this problem. Now you also try to answer in the chat box what should be taken, how it should be taken. I will ask you now. By this time you got idea. So one more convex lens related problem. Now you can answer in the chat box what is that 4 centimeters there. An object 4 centimeters height it is given. So what is that? What is that 4 centimeters indicates there? What is that 4 centimeters indicates there? What that 4 centimeters indicates there? Can you hear my voice clearly? 4 centimeters is height of the object. The object should be taken always positive. HO should be taken always positive, so it is plus 4 centimeters. One more. He is placed at a distance of 10 centimeters from a concave convex lens of focal length 20 centimeters. So what is that 10 centimeters indicates there? What is that 10 centimeters indicates there? What the 10 centimeters indicates? Ten centimeters is what object distance. Object distance is equal to object distance which will be taken negative. So object distance u is equal to minus 10 centimeters. And then focal length is also given. Focal length. Focal length of convex lens. That is important. Convex. Because it is convex, we should take it as positive. So it is plus 20 centimeters. Now what they are asking to find first one position of the of image. So what 1 by v minus 1 by u is equal to 1 by l. 1 by v minus 1 by u is equal to 1 by f. 1 by v we do not know minus 1 by u is what? Minus 10. So it is minus of 1 by minus 10 is equal to 1 by f, 1 by 2. Now this is 1 by v minus into minus plus 1 by 10 is equal to 1 by 20. So transpose 1 by 10 other side. We get 1 by v is equal to 1 by 20 minus 1 by 10. Now we can take LCM here. 1 by v is equal to LCM is 20. Now here 1 as it is. Here we have to multiply 2 to 10 to get 20. So it is minus 2. 1 minus 2. So 1 by v is equal to 1 minus 2 is minus 1. So minus 1 by 20. By this what we understand? V is equal to minus 20 centimeters. So V we got negative. When we get V negative, which side image is forming? Left side. When left side it is forming, it is virtual and direct image. Virtual and direct image. You know, you can observe clearly if you see the position. This is optical center O, principal axis. This is F1. This is 2F1. This is F2. This is 2F. Now, if you observe, focal length is 20 centimeters. So from here to here 20 centimeters. But object distance is 10 centimeters only. So where object is kept between F1 and optical center. So it is that one case where object forms same, where image forms same side of the object. So it is different case. Five total six cases. It is a different case when object is between optical center and F1. It is same side of the object, that is same side of the image is same side of the object and it is virtual and direct. That's why we got this side image is forming, that's why it is minus 20 centimeters. And it will be magnified image if we find the nature also they are asking to find, so it is virtual and direct. Size of the image also they are asking to find. How can we find size of the image now? We know hi by ho is equal to b by u. Height of the image we have to find hi by 4 is equal to v. V is minus 20 by U is minus 60. U is where we got U. So U is minus 10, not 60, minus 10. Minus minus cancel. Transpose 4 there. HI is equal to mean 4 centimeters. So it is magnified image. Virtual and direct magnified image. So you have to write the nature of the image. Nature is what? Virtual and image, virtual and direct. Height of the image 8 centimeters is magnified image. Hope you understood this solution also. Hope all these up to here, these all are clear. Now let's see one problem related to concave lens and then we continue. Concave lens. Oh, maybe. Concave lens is similar to do like convex mirror. Position only two positions will be there. You will be having only virtual and direct image. In the two positions, you will be having only virtual and direct images will form. So now here what information is given? An object is placed at a distance of 4 centimeters. So object distance is given. Object distance u is equal to minus 4 centimeters. One more focal length is given. Focal length or concave. This is very important. Concave lens. So f is equal to, because it is concave, we have to take minus 12. So now what we have to find? Position of the image. 1 by v plus minus 1 by u is equal to 1 by f. This is the formula. So here 1 by v minus of 1 by minus 4 is equal to 1 by minus, that is 1 by v plus 1 by 4 equal to 1 by minus 2. Transfer this plus 1 by 4 back side. You get 1 by v is equal to 1 by minus 12 minus 1 by 4. Now we will take LCM. 1 by v is equal to LCM for both is 12. So we want minus 12. So what do you need to multiply? Minus 3. So minus 1, because it's already minus 12 there. So minus 1 we have to multiply to get plus 12. And here minus 4 we have. So minus 3 should be multiplied. So what is 1 by v is equal to minus 4 by 12. Then after cancellation you get 4 on the 4 3 is 1 by v is equal to 1 by 3 minus 1. Centimeters. Means by this again you should understand it is a virtual and direct image. So image forms it. First one, image distance is minus 3 centimeters, and nature is it is virtual and direct. Virtual and direct. Virtual and direct image. And you know one more word, it is diminished. You hope you got some idea about numericals related to mirrors, lenses, the refractive index. So you know you need more practice to get perfection in this. If you practice this, definitely in your final exam you can solve problem related to light in science, especially in physics. Light and electricity you have to be perfect to solve all the questions related to numericals. Hope this video will help you to understand better. Thank you.